Okay, this video is on the Pythagorean Theorem and its converse. Most of this should be a review. First off, we want to talk about the geometric mean. And so algebraically, there's kind of a pattern that looks like this. So if we want to talk about the geometric mean between 4 and 6, we're actually looking at something like a ratio of 4 is to x as x is to 6. Notice that the 4 and the 6 end up diagonal in this set of ratios. So when we cross multiply, we get x squared is equal to 24, and x is going to be the square root of 24. Now 24 is the same thing as what's the biggest perfect square? We got like 4 times 6. So we got the square root of 4 times the square root of 6 makes square root of 24. Square root of 4 is 2. So we end up with 2 square root of 6. Decimal-wise, the square root of 24 is a little bit less than 5. So we might guess like 4.9, something like that, approximately. Okay, so we want to talk about the geometric mean between 14 and 56. Same idea, 14, 56 in the corners, x in the other corners. Cross multiply, x squared is whatever 14 times 56 is, and then x is going to be the square root of 14 times 56. For number 2, same idea. X is to 12 as 32 is to x. Notice I got the x's in opposite corners here. Still, when we cross multiply, we get x squared is equal to 12 times 32. And x is going to be the square root of whatever 12 times 32 is. Let's look at these next ones. Solve each equation for x. So we want to take the square root of both sides. So the square root of x squared and the square root of 144. Square root of x squared is x. The square root of 144 is 12. Now here we're talking about the principal square root. Principal square root with an LE, and that's the positive square root, but notice that there is also a negative square root. So negative 12 times negative 12 would be 144, and 12 times 12 is 144. So always remember there's also a negative root. Here to simplify this one, ultimately we want to take the square root of both sides, but we got to get rid of this 3 first. So we divide both sides by 3, we get x squared is equal to 108 divided by 3, which is going to go 3 times, it's going to be 36, and x is going to be the square root of 36, which is going to be plus or minus 6. Here we have 2x squared minus 7 is equal to 91. Get our numbers together, add 7 to both sides. 2x squared is equal to 98. Divide both sides by 2. X squared is equal to 49. Take the square root of both sides. X is equal to the square root of 49, which is plus and minus 7. So that's how we would do those. Let's talk about the Pythagorean Theorem. We've done this before. If you have a right triangle, and we usually let C be opposite the right angle, A and B can be either one of the other two legs, we can say that A squared plus B squared is equal to C squared, or usually, more usefully, C squared is equal to the square root of A squared plus B squared, or C is equal to the square root of A squared plus B squared. So let's see. So this Pythagorean theorem only works for right triangles. It's used to find a side length. A and B are the legs, and C is the hypotenuse. Let's look at some examples here. We want to solve this for x. So we've got the c is opposite the right angle. So we have 6 squared plus 8 squared is equal to x squared. 6 squared is 36. 8 squared is 64. Equal to x squared. Flip it around. X squared is equal to 100. X is going to be plus and minus 10. But now we're dealing with distances, so we're really just taking about this principal square root, which is a 10. Let's look at number 2. Here's the hypotenuse is a 20, so 20 squared goes in the C position. A squared or B squared is x squared, and then we have 16 squared. So x squared plus 16 squared is equal to 20 squared. Take away 16 squared from both sides. X squared is equal to 20 squared minus 16 squared. Okay, we need to multiply these out. This is going to be 400. Take away 256. That's going to give us 144. X squared is 144. X is going to be the square root of 144, which is 12. Because we're doing the positive because it's distance. For number 3, we've got an 18 for the hypotenuse. So that's going to set up 18 squared on the right. And we have x squared plus 15 squared is equal to 18 squared. 18 squared is 196. X squared, 18 squared is 296. And 15 squared is 225. Take 225 away from both sides. We get x squared is equal to, it's like 71. And x is going to be the square root of 71. Now, I may be off on the calculations on this. I'm not going to take time to check it because I'm just, but 18 times 18 might not be 296. These have come out to be perfect squares, so I'm thinking that might be something we need to check into further. So look at number 4. 10 squared and 16 squared is equal to x squared. So we got 100 plus 256 equals x squared. X is going to be the square root of 356. Here we have 16 and 30 for the legs with an x for the hypotenuse. So 16 squared plus 30 squared equals x squared. 256 plus 900 equals x squared. X is going to be the square root of 1156. Here we have 2 5s with an x for the hypotenuse. So we got 5 squared plus 5 squared is equal to x squared. 25 and 25 is 50. 50 is equal to x squared. X is going to be square root of 50. This is a little bit bigger than 7. Now, the converse of the Pythagorean theorem is kind of useful. Like if you use the Pythagorean theorem and it turns out that a squared and b squared is equal to c squared, then you know you have a right triangle. But if a squared and b squared is greater than c squared, then you have an acute triangle. Think about opposite. Greater than, acute is an angle smaller than 90. And if a squared and b squared is less than c squared, then you have an obtuse triangle. Again, the opposite idea works. Less than c squared, you're talking about an angle greater than 90, the obtuse angle. So we want to classify these triangles. So we've got 6, 5, and 4. So our check, what our check is the 4 and the 5 squared equal to, greater than, or less than 6 squared. 4 squared is 16. 5 squared is 25. That adds up to 41. and 41 is greater than 36, which is 6 squared. That means this is an acute triangle. Greater than goes with an angle less than 90. Look at number 7, or number 8 rather. 3, 4, and 7. So 3 squared is 9. 4 squared is 16. That gives us a 25. 7 squared is 49. So in this case, 25 is less than 49. So we have an obtuse triangle. An opposite, less than means angle bigger than 90. Here we have a 2, 10, and a 6. So we have to look at the longest side length as being the hypotenuse. There's sort of a trick in the order here. So basically we're checking to see if 2 squared plus 6 squared and how that relates to 10 squared. So 2 squared is 4, 6 squared is 36. That gives us 40 versus 100. And 40 is less than 100. That means this is going to be an obtuse triangle. And that's all there is to that.